back to the Inequalities unit. Today we're going to be talking about solving inequalities using practical problems. So let's get started with that by taking a look at a few vocabulary terms. So below in our vocabulary terms chart there, we can see a few things that stand for less than or equal to, greater than or equal to, less than, or greater than. Are these all the words that you will see meaning these things? No, but they're an excellent start for us. Now let's put them to practice by doing example A. So here in example A, it says write and solve an inequality. So our problem says Mrs. Smith charges $30 per hour for tutoring services plus a one-time fee of $10 for supplies. How many tutoring sessions can a student attend if the parent will spend at least $1,000? So the first thing we're going to do is go through and highlight our important mathematical information. So we can see that charging $30 per hour is an important piece of information. A one-time fee of $10 is important for information. And at least $1,000 is important information. Now, this is important because it tells us where to find our variable, where to find our constant, and where to find our most important inequality symbol. So when we're talking about at least $1,000, that means that they can spend $1,000, but they can also spend more than $1,000. We want them to spend at least that, but they could spend over it. They could spend $2,000, they could spend $3,000, they could spend $10,000 in tutoring, but we have to make sure that we're getting at least that. So we know the amount of hours spent tutoring has to be greater than or equal to 1,000. And we know that because it says it needs to be at least 1,000. Now let's take a look at some other information from our problem. So we know that she's charging $30 per hour. And since we don't know how many hours that is, that's going to be our x. So we're going to write that as 30x. We also know that she's going to be adding plus, we see plus there, the word plus means addition, a one-time fee of $10. So we're going to put plus 10. Now we've made our inequality, the next thing we need to do is solve. So we're going to draw our wall down from our inequality symbol, subtract 10 from both sides to get rid of our constants. Positive 10 and negative 10 are going to cancel. Bring down our 30x. We didn't multiply or divide by a negative, so our sign stays the same. 100 minus 10 is going to be 990. The last thing we're going to do is divide both sides by 30. So divide by 30 on both sides. These are going to cancel. We did not multiply or divide by a negative, so our sign stays the same, so greater than or equal to. 990 divided by 30 is going to be 33. So x is greater than or equal to 33. What does that mean for our problem? This means that the student will attend 33 sessions or more, or 33 hours or more. Now let's take a look at example B. Here in example B, it says write and solve an inequality. Amanda ran 4 laps around the school track. Martha ran half as many laps as Tay ran. Together, the 3 friends ran no more than 13 laps. What is the most amount of laps that Tay could have ran? So, first thing we need to do is highlight our important information. So, Amanda has run 4 laps. That's important. Martha has ran half as many. That's important. Together there are 3 of them, which we know, and the friends ran no more than 13 laps. So the no more than is going to be important. What is the most amount of laps that Tay could have run? So those are our important pieces of information. So the first thing we need to do is figure out our inequality symbol. And here our problem said ran no more than 13 laps. So that means they have to run no more than, they can't have an amount larger than 13. They can't run 14, they can't run 15. They can run 7, that's less than 13, but they have to run no more than that. So our inequality symbol is going to be less than, let's make sure we got a pen there. We're going to make sure that we're going to have less than or equal to 13 laps. So now we need to include our 3 friends. We don't know how many laps that Tay ran. She seems to be the crux of the problem here. We don't know that, so she's going to be our x for Tay. We're going to add to that the number of laps Amanda ran, and she ran 4 laps. No variable there. They told us how many she ran, so that's our constant. We're going to add 4. And then it says that Martha ran half as many laps as Tay ran. Now we can write this as many ways. We can write 1/2 times x. We run 0.5 times x. We can put x over 2, whichever works for us. I'm going to put 0.5x. I think it's a little easier to work with decimals, but you could use fractions in this case. Either one is correct. Now we need to solve our inequality. So we're going to start by drawing our wall down, and then we need to see if we have any like terms, which we do, because x and 0.5x are like terms, we need to combine them. So when we combine x and 0.5x, we're going to get 1.5x plus 4, bring down our inequality symbol, we didn't do anything with that, bring down our 13. The next step that we need to do in our problem is we need to make sure that we get rid of our constant. We're going to eliminate our constant by subtracting 4 on both sides. These are going to cancel, bring down 1.5x. 13 minus 4 is going to be 9. Then we need to divide both sides to finish off our inequality. Divide both sides by 1.5. The inverse of multiplication is division. These are going to cancel, bring down our x. We did not multiply or divide by a negative, so our sign stays the same. 9 divided by 1.5 is 6. So our answer is x is less than or equal to 6. So what does that mean? This means that the most laps Tay could have run was 6. Now let's take a look at example C. Here we are at example C, and it says David currently has 22 baseball cards and he plans to buy 6 baseball cards per week. David's friend Albert also has baseball cards. Albert has 4 baseball cards and plans to buy 12 baseball cards per week. After how many weeks will Albert have at least as many as David? So let's start first by highlighting our important information. So David currently has 22 baseball cards. That's important. He plans to buy 6 baseball cards per week. David's friend Albert is also collecting. He has 4 cards to start with, and he's going to buy 12 per week. So we can agree that Albert has less than David because he's starting with 4 and David's starting with 22. So we need to figure out after how many weeks will Albert have at least as many as David. So we have 2 people here that we're going to be comparing. One side is going to be David. One side of our inequality is going to be Albert. It's important to label these 2 sides so that you know what you're working with. So we're going to start by putting David on one side, and we'll have Albert on the other. Now, we know that David has 22 cards to start, so we're going to put his 22 here, and he's buying 6 cards per week, so we're going to add 6. We don't know how many cards that's going to be, so that's going to be our x. On the other side, we're going to deal with Albert here. How many cards does he start with? He starts with 4, and he's going to be adding 12 cards per week. We don't know how many weeks, so that's going to be our x. Now, we need an inequality symbol between the 2. It says Albert has at least as many as David. So we want him to have as many as David, but also he could have more than David. He can't have less than them. That wouldn't be the answer to the problem. So we need to make sure that our greater symbol is pointing towards Albert because we want to know when he is going to have at least, so have the same, or more than David. So now that we've identified where our symbol belongs, we're going to draw down and we're going to solve. We've got variables on both sides, so we can start by getting rid of one of them. It doesn't matter which thing we move as long as we are consistent. I'm going to get rid of my 6x first, moving my variables by subtracting 6x. You could get rid of the constants. You could get rid of the 12. The choice is up to you. These are going to cancel, bring down my 22, bring down my inequality symbol, bring down my 4. 12 minus 6 is 6x. Now we need to get rid of our constant, so we're going to do so by subtracting 4 on both sides. 4 minus 4 is going to cancel. 22 minus 4 is 18. Bring down our inequality symbol, bring down our 6x. The final step here that we have is we need to divide both sides by 6. Divide both sides by 6, and x is going to be greater than or equal to 3. So what does this mean? It means it will take 3 weeks or more for Albert to have at least the same amount of cards as David. Now let's take a look at example D. So here we are at example D, and by far the trickiest problem that we've faced. Aisha is updating her wardrobe. She purchased 3 tops and 5 skirts. Each top costs $6.25 less than the cost of a skirt. Aisha could spend no more than $202.21. How much could each skirt cost no more than? So let's start by highlighting our important information. So it's important that she purchased 3 tops and 5 skirts. It's important to us that the tops cost $6.25 less than the cost of a skirt. So that whole part is important. She could spend no more than $202.21. So we need to know the cost of a skirt. All right, now this is all important information, but this is going to get a little bit tricky. So we're going to start by figuring out what our x is in this problem. So our x in this particular case is going to be the cost of one skirt. And that's very important to remember to start with because we want to make sure that when we compare tops and skirts, that we're using the x in the right place. So since it says how much could each skirt cost no more than, the cost of the skirt is going to be our x. Now let's find our inequality symbol, and it says Aisha could spend no more than $202.21. So since she could spend no more than, that means we can't spend $205, we can't spend $207. The maximum amount she could spend is $200.21. So we're going to have less than or equal to $202.21. Now we need to start putting in the other parts of our problem. So how many skirts did she buy? It appears that she purchased 5 skirts, and we don't know how much each skirt costs, so 5x. That part is pretty easy. Now we need to purchase 3 tops. Now here's the key. Here's the part where this gets tricky. We're going to add those 3 skirts, but we can't just put in 3x because x is the cost of a skirt, and our tops don't cost the same as a skirt. So in order to do that, we need to do subtraction of $6.25 because there's $6.25 less than the cost of a skirt. So we need to write that as x minus $6.25 for the top. However, that would only give us one top. If we did x minus 6.25 one time, we would only be taking $6.25 for one of the tops. But we're buying 3 tops. In order to represent that, we need to have parentheses around our x minus 6.25 because we need to multiply that times 3 because we're buying 3 tops. That's the trickiest part of this. So if that part was a little confusing, feel free to pause, rewind, hear it again. But we're putting the parentheses around the x minus 6.25 because we're subtracting $6.25 every time we buy a top. Not just one time because we're buying 3 tops. Now that we've got our problem written, we can start to solve. So we're going to draw our wall down from our inequality symbol, and we need to see if we have any simplification. So we need to start by distributive property. 3 times x is going to be 3x. 3 times negative 6.25 is going to be 18.75. So we're going to write that down, minus 18.75. Bring down our inequality symbol. We didn't do anything with that. 202.21, didn't do anything with that. Now we need to simplify again because we have to combine our like terms. So 3x and 5x is going to give us 8x. Bring down our minus 18.75 because we didn't do anything with that. Inequality symbol stays the same. Total stays the same so far. Now we need to get rid of our constant. We're going to do that by adding 18.75. The opposite of subtraction is addition. These are going to cancel. Bring down our 8x. We didn't multiply or divide by a negative, so our sign stays the same. $202.21 plus 18.75 is going to give us $220.96. Our final step in this problem here is to do our division. We're going to divide both sides by 8. When we do that, these are going to cancel, and x is going to be less than or equal to $27.62. So, what does this mean for our problem? This means that each skirt could cost no more than $27.62. Now, if we wanted to find the cost of a top, we would just do 27.62 minus the $6.25. That brings us to the end of this problem. It also brings us to the end of this set of notes. If you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.